Welcome to this short demonstration of real vibrations seismic motion analyzer. We built this system for a client who had purchased a 2 degree of freedom seismic table. This system will work with any standard or well-known data acquisition system such as data translation, national instrument, measurement computing and so forth. Currently we have a small National Instrument 6009 connected to the system, and we have two dual axis accelerometers connected to the data acquisition module. The system was designed to be very easy to use, so here we have the main layout, which shows the excitation and response signals for the X direction, and we're measuring acceleration, of course. And on the right we have the corresponding frequency spectra in the X and Y direction. Of course, this system can be scaled up to any number of channels. At the moment on the shaker table we have a small multi-story structure with the accelerometer or the response accelerometer mounted at the very top of the structure. So to start the system is fairly straightforward. We'll set up the accelerometers. And we have the sensitivities which are all 500 millivolts per G, so this is fairly straightforward. And we have the acquisition. We want to trigger the system, so we'll trigger off the accelerometer in X orientation or X axis, and we set the trigger level to 0.5 G, and we can set the trigger condition as rising and falling. We can capture data prior to the trigger, and we capture, say, 8 seconds of data post-trigger. That way you can activate the system and simply turn on the shaker table at leisure, and the system will record automatically. So here we're ready to record, so I'll collect the data and we'll set the trigger. The system will start and will generate some vibrations on the shaker table. And here we have it. So the excitation signal in the X and Y are the yellow curves, and you have a corresponding spectra, and the blue lines are the response accelerations. One of the features of a system is, especially for education purposes or others, we can integrate the acceleration data to obtain velocity waveforms as well as velocity spectra. And of course we can further integrate to obtain displacement. And finally we can also display areas intensities for the excitation and response. Another interesting feature we have is to display the trajectory. So the trajectory information for the table and the response are based on a calculated displacement. And here this is what happened just now, with the bottom cube representing the accelerometer mounted on the shaker table, and the top mounted on the top of a building. And of course, here what we can do is we can also view the motion of the system in any perspective, and that can be done really during animation. So we can look at it sideways, look at it from a different perspective. And interestingly, this video file can be saved, so for teaching or demonstration purposes it can be done. And finally, a feature which was requested of us was to be able to export all the data to Excel. This takes a little while, but it's done. And now if we look at the data folder, and we'll see today, this is a data file from today, and if we open Excel, this will open Excel, and what we can see is all the acceleration waveforms. This was sampled at 100 Hertz, um, the excitation and response or accelerations, and we have the calculated velocities, displacements, areas intensity, and the corresponding acceleration spectra, the velocity spectra and the displacement spectra. So everything's there for end users to plot their own spectra and so forth. This is, as you can see, a very simple system to use, and it works very well with our vibration controllers that can be used to synthesize or simulate multi-axis seismic motion on multi-axis shakers. And I do hope you have enjoyed this short demonstration, and do visit us on our website if you have any queries. Goodbye.